Your goal after watching this video is to be able to calculate the area of triangles. So first, the area of a triangle. Remember, area talks about how many square units can cover the surface of that triangle. So we're still talking square units. Area is still going to be units squared or inches squared or centimeters squared, even though we're dealing with triangles. We're still saying how many square units can cover up the surface of this triangle. And to calculate that, you multiply the base times height, just like you would for a parallelogram, rectangle or square. But then, as you can see, this is not a full parallelogram. But then you take the base times height and after you multiply it, you divide it by 2. So you only want half of the base times height. We could either view this as dividing base times height by 2 or taking 1/2 times base times height. Okay, so find the area of this triangle. So here we have A, or area, equals 1/2 of the base times height. And from this picture, we know both the base and the height. So I'm going to rewrite this. We don't know the area, but I know half. All right, remember half is the same as 0.5. So if you want to do this on your calculator, instead of typing in the fraction 1/2, you could type in 0.5. So 1/2, or 0.5, times the base. All right, here's the base of our triangle. So base is 5. Height, your height of your triangle is a line perpendicular from the base, so forming a right angle with the base to the highest point of the triangle. So this is the height. This is not the height. The height is 8. All right, so if I would say, okay, base times height right here, that's 40. All right, what's half of 40? Or what's 0.5 times 40? 20. All right, and here we're talking inches. So we have 20 inches squared. That's saying if I had 20 of those little square inches like we used in class for the area scavenger hunt, if I had 20 of those, it would cover the area, or it would cover the surface of this triangle if this triangle in real life was actually 5 inches by 8 inches. All right, so now they're saying, is our answer reasonable? So they drew a triangle on grid paper with 1-inch squares. All right, so in real life, these squares measure 1 inch by 1 inch. They're the same size we used in class. So they drew the triangle, and they're saying if you counted the squares, would it be about 20? All right, so if we count the pink ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the pink ones are ones that are almost full squares. All right, so we have 18 square inches that are full, but then we have some halves. So we could say, okay, maybe these two halves go together to form another 1-inch square. And maybe these two halves go together to form another 1-inch square. This little corner right here and this little corner right here, well, they can maybe go to make a full square inch with that one, because that one wasn't really a full one, it was just close. So do I have approximately 20 square inches covering that triangle? Yes, I do. So it looks like my answer is pretty reasonable. Okay, find the area of this triangle. So for this triangle, again, we're using area is 1/2 of the base times height. So they said that the base is 12. All right, the base is 12. And then remember, the height is a line that's perpendicular to the base, going to the highest part of the triangle. So if we use 12 as the base, here's the highest part of the triangle right here. So we need a line going perpendicular to the base. Since we drew a line perpendicular and the base isn't there, they just extended an imaginary base line out right there. That's what that red part is. So our height is 9. So they substituted 12 and 9. And then they said, okay, base times height, 12 times 9 is 108. And then we needed to take half of that because a triangle isn't a full rectangle. A triangle is only half of a parallelogram. So 12 times 9, and then half of that, or 0.5 times that, is 54. And something's missing here because we don't just say 54, we have to be specific. It's 54 square meters. All right, so if this triangle in real life really measured 12 meters by 9 meters, it would take 54 square meters. Think about a meter stick. So squares that are the length of a meter stick on each side, 54 of those to cover up that triangle surface. All right, last one. The base and height of the red butterfly wing are 2 times greater than the base and height of the blue butterfly wing. How many times greater is the area of the red wing than the area of the blue wing? Okay, so we want to find how many times greater is this one than this one. So first, let's find the area of the blue butterfly wing, okay? So we know that since the blue butterfly wing is shaped like a triangle, we can use area equals 1/2 of the base times height. So this is the blue one again. All right, so we don't know the area, that's what we're trying to find. But we're going to take half of the base. The base is 2. All right, centimeters. And the height, all right, a perpendicular line from the base, so a line forming a right angle with the base all the way to the highest point, is 1 centimeter. All right, base times height, or 2 times 1 is 2. 1/2 of 2 is 1 centimeter squared. All right, so the area of the blue butterfly wing is 1 square centimeter, or 1 centimeter squared. Then, our word problem says the base and height of the red butterfly wing are 2 times greater than the base and height of the blue butterfly wing. So if the base of the blue is 2 centimeters, the base of the red is 4 centimeters. And if the height of the blue is 1 centimeter, the height of the red is twice that, or double that, which would be 2 centimeters. So now, the question is, if the base is twice as long as the blue one, and the height is twice as long, will the area be twice as much? What do you think? Let's find out. So area is 1/2 of, or 1/2 times, the base times height. Remember, these are connected by multiplication. If there's nothing between variables or numbers and variables, it means multiply. So area equals 1/2. The base is 4 centimeters. Base times height. The height is 2 centimeters. Okay, so let's find the base times height first. 4 times 2 is 8. And then half of 8 is 4. And we have centimeters times centimeters, so 4 centimeters squared. So the area of the red butterfly wing is 4 centimeters squared. And the area of the blue butterfly wing is 1 centimeter squared. So even though the base doubled and the height doubled in the red butterfly wing, right, the area, did the area double? From 1 centimeter to 4 centimeter? No, right? The area of the red butterfly wing is 4 times greater. And that's the answer to our question. How many times greater is the area of the red wing than the area of the blue wing? 4 times greater.